In this video, we're going to be finding an equation of a hyperbola given one vertex and two foci. We'll find an equation of the hyperbola having one vertex at 0, 2, and foci at 0, 3, and 0, negative 3. Then we'll graph the equation. Since the foci are located at 0, 3, and 0, negative 3, their midpoint is at 0, 0, the origin. This means that the center of the hyperbola is at the origin. Because the foci lie on the y-axis, the transverse axis is along the y-axis. Here's what we have so far. A vertex at 0, 2, foci at 0, 3, and 0, negative 3. The other vertex will be located at 0, negative 2 to maintain symmetry. And since this is a hyperbola centered at the origin with the transverse axis along y, the form of the hyperbola is y squared over 4 minus x squared over 5 equals 1, where a squared equals 4 and b squared equals 5. Since our foci occur at 0 plus or minus 3, we can let y equal plus or minus 3 to obtain additional points. This gives us plus or minus 3 squared over 4 minus x squared over 5 equals 1. Plus or minus 3 squared can be written as 9. So now we have 9 over 4 minus x squared over 5 equals 1. Solving for x will give us x equals plus or minus 5 halves, and you may want to pause the video to work that out on your own. And at this point we're ready to graph the hyperbola. We have our vertices at 0, 2 and 0, negative 2. We have our foci at 0, 3 and 0, negative 3. We have additional points at 5 halves, 3, and negative 5 halves, 3. This allows us to draw the first branch of a hyperbola. Our other additional points occur at 5 halves, negative 3, and negative 5 halves, negative 3. We sketch our second branch of the hyperbola. This completes our graph and concludes our example. See you next time.